This is my semester exam project, part 3. My learning target is A5C, and it covers Chapter 5, Sections 1, 2, 3, 6, and 7. And it's done by me, Cameron Perdido. In Chapter 5, Section 1, we're introduced to terms such as function, domain, and range. And a word problem saying, a hipster goes to Whole Foods and buys a container of freshly ground peanut butter for 25 cents an ounce. The function f of x equals 0.25x gives the total cost of the peanut butter after the x number of ounces. Graph this function and give its domain and range. Well, to first start off this problem, we're going to need to plug in the x value into the function to know where to graph the points. So after we plug in the value, we know where to graph the points. And after graphing the points, we draw a line through them to represent the function. After we graph the function, it tells us to give the domain and range. And the domain is basically a synonym for the x value or the independent variable. And in this case, it's the number of ounces. So the domain in this problem is 1, 2, 3, 4, and 5. And the range is the dependent variable, or the y-axis, in the problem. So the costs are 25 cents, 50 cents, 75 cents, $1, and $1.25. And this problem has our function graphed and states our domain and range. And we have answered all the questions to the problem. In Chapter 5, Section 2, we're taught how to find the x and y intercepts of the equation. So our example equation will be 2x plus 5y equals 10. In order to first solve this, we must find one of the variables first. So in this case, let's try to find the x intercepts. In order to do that, we must let y equal 0 in the equation, and then we plug in the values. And from there, we just isolate the variable. And this is how we figure out that the x-intercept is 5. And we basically do the same thing to find the y-intercept, but we first let the x value equal 0 instead of the y. And then we plug that value into the equation. And from there, we isolate the variable. And this is how we figured out that the y-intercept is 2. And this is how you find the x and y-intercept of an equation. In Chapter 5, Section 3, we're introduced to the concept of rate of change. In a word problem, it says, a hipster goes to Joe's coffee shop on SoCo for over 10 years. One day he realizes the price of his iced dirty soy chai latte has changed over time. The table shows the cost of his favorite hipster drink throughout the different years. Find the rate of change in cost for each time interval. During which time interval did the cost increase at the greatest rate? Well, there are 2 steps to solve this problem. The first step is to identify the dependent and independent variable. The dependent variable would be the cost of the hipster's drink, and the independent would be the number of years. The second step would be to find the rates of change. And in order to do that, we take the change in cost and divide that by the change in years. So from 1990 to 1995, we see that there is a 50-cent difference over the span of 5 years. And we can identify that that would be a 10-cent per 1 year rate of change. And if we apply this method to the other intervals, we can identify we can identify the different rates of change. And the second part of the question says, during which time interval did the cost increase the greatest time? By looking at our data, we can see that the cost increased at the greatest rate from the year of 2001 to 2007. And that's how we identify the rate of change. In Chapter 5, Section 7, we're taught how to write an equation in slope-intercept form when given two coordinate values. So in our example problem, let's say our coordinate values are 4, -1, and -2, 8. Our first step would be to find the slope. In order to do that, we use the equation y2 minus y1 divided by x2 minus x1. If we plug in our values, we find that our simplified slope would be -3/2. And from there, all we do is substitute the values into point slope form. Point slope form is y minus y1 equals m times x minus x1. When we plug in our values, the equation would now look like and from this point here, all we do is solve for y and isolate the variable. So after doing that, we find that our final answer in slope-intercept form is y equals -3/2x plus 5. And that's how we write an equation in slope-intercept form when given two coordinate values.